Hello, this is the Math Help Center. This is Mia. How may I help you?
Hello. Hi, Mia. I need help. I don't understand particle motion, and I'm in math class, and I hate going every day, and it's just awful. Please, can you help me?
Calm down, Hannah. You can come in at 4590 Vector Avenue, and we have an open slot at 1:30 with the doctor. I'll see you then.
2 hours later.
Hi, Hannah. Welcome to the Math Help Center. You're going to be okay. I'm the math doctor.
The first thing you need to know is the definition of particle motion. Particle motion is the movement of a point along a graph.
Okay, Hannah. So we're going to talk about three main topics today. These 3 points are the positive and negative movement, increasing and decreasing, as well as concave up and concave down of the graph itself.
Alright, Hannah, so first we're going to learn about the positive and negatives of particle motion. So I have my axis here, and I'm going to draw an F graph, a random F graph. Let's say it goes like this. Okay? So we'll label that as the F graph, which means it is the main and the original function. Now I'm going to draw the F prime graph. And to do this, I look where my zeros are. And this slope is increasing, which means my graph will be above. And then it goes to decreasing all the way until this point. So my graph will be below the x-axis. And then it goes back to above. So I have a nice parabola. So I will label this as F prime. And finally, I have to draw my F double prime. This is negative, so we're going to start negative and go all the way up. And we'll label that as F double prime. All right. I'm going to draw lines at my points. Remember, these aren't part of the functions. They're just to show me or help me decide when it's positive and negative. So to understand these positive and negatives, we're going to look in this first full section right here. Let's look at our blue line first, the F function, and see that it is positive in here. Okay, positive. And we'll look at the black line, which is F double prime, and it is negative because it is below the x-axis. And finally, the F prime is positive because it is above the x-axis.
Okay, Hannah, so for the next part, we're going to talk about increasing and decreasing. So let's take Elena's graphs here and this flower. So you have the flower on the graph of F, and as you move the flower, F prime is decreasing. You're going to continue moving, and F prime will continue to move until you hit 0. When you hit 0 and the slope becomes negative, this is when the graph of F prime begins to increase. And as you continue moving, the graph of F prime will also continue to increase. And now, if we take the flower and move it to F prime, you can see that F prime is a consistent curve. And this you can see through F double prime, which is continually increasing. Now, we can take it back and connect it to what Elena was talking about with positive and negative.
Great idea, Alli. So, as you can see, what Alli said, as F is increasing up until this point, F prime is positive. Now to tie in F double prime to this, as you can see, F double prime is constantly increasing. And when F double prime is negative, below the x-axis, we can see that F prime is decreasing. And as F double prime goes above the x-axis, F prime is increasing.
Lastly, we'll look at concavity. First, we'll look at the blue graph, which is the F graph, and you can see it is concave down. Then we'll look at the red graph, which is F prime, and you can see it is decreasing. And lastly, we'll look at the black graph, which is F double prime, and you can see it is negative. Then we'll move over to the other side, and we'll start with the blue graph as well. Here it is concave up, which means that the red graph is increasing, and the black graph is positive.
Now that we understand how these three graphs are related, we can look at them in terms of particle motion. We can look at F as the position function. We can look at F prime as velocity, and F double prime as acceleration. Let's say this point is 2 and this is 1. This is the position of the particle. So the position here is at 2. Up here, let's say this is 2. If we look at the F prime, we can see that at position 2, F prime is going at a speed of 2.
So what you're saying is, when F is concave up, F prime is increasing. And when F prime is increasing, F double prime is positive. And I guess that would make sense if you do it this way too. When F is increasing, F prime is positive. So it's the same with the sad face. When F is concave down, F prime is decreasing. And when F prime is decreasing, F double prime is negative. And same the other way. When F is decreasing, F prime is negative.
Wow, Hannah, that's really impressive. You've come a long way during our session today.
Yes, Hannah, it's as easy as using the faces. Let's try it on this practice problem. So, a particle is moving along this line. The graph of the particle's position of x of t at time t is shown on this graph from 0 to 6. Now, for what values of t is the velocity of the particle increasing?
So since this is the graph of F, when F prime is increasing, F must be concave up, here. So from 0 to 3.
Okay, Hannah, that first one was perfect. Now I've drawn a second graph that's a little bit more challenging because it's the graph of f prime. So, to make sure you really understand, I want you to explain to me what's going on to the other functions in this graph.
Okay, well, from -2 to -1, because F prime is decreasing, F must be concave down. And F double prime must be negative. And
Perfect.
over here, F prime is increasing, so F double prime must be positive, and F must be concave up, right?
That's perfect, Hannah. You've really mastered the topic of particle motion. Here, Hannah, now on your way out, I'm going to give you these 2 send-away problems for you to do at home. Bring them back in a week to make sure that you really understand particle motion.
Okay, thank you. See you next week.
I'm going to split up this graph party here.
Party down. Stop! Which is F prime, and you can see. Oh, what was I going to say?
Okay, Hannah, that first one was perfect. Now we're going to look at one that